Hello and welcome to our Friday half-term maths revision live stream. What am I going to do today? It's a little bit of a mixed bag today. I have one A-level question that I'm going to do, and then a GCSE level question that I'm going to do, and then we'll see what it is, how it goes from there. But not a lot on the plate today because it's a Friday, and well, I don't imagine a lot of people are going to tune in today. Typically, people aren't watching a lot of maths videos on a Friday, but we'll see how we go. Hello, Nicholas. Welcome. So I'm going to tackle this question first. Before I get into it, well, it's been a live stream every day this week since Tuesday. So I would appreciate if you did tune into any of the live streams. Well, I'll kind of mention that towards the end, but I would love some feedback on what you thought of the live streams, if you thought they were a good way to learn, etc. I've put a few questions in the description, if you could, but I'll talk about that a bit more towards the end. Hello, George. Welcome. What else? Yeah, it's been a live stream since Tuesday every day. I'm just kind of, I'm wondering how it went really. So I'm wondering what you all thought of it, if this is a good idea. But yeah, it's been a busy week. I hope your revision's been going well, or if you decided to take a break, I hope you had, a chance to, what's the word? A chance to get your energy back, ready to get back into it after the break. So I'm only doing this one A-level question, and this would be appropriate for any exam board, I would say. And I wanted to highlight one aspect of this question that I think is not that commonly kind of covered in the specification. In fact, I couldn't find any mention of it in the specification, but this is from an A-level practice test, so I assume it must be in there somewhere. I just couldn't find it in the actual specification itself. Hello, Minat. Yeah, I'll put a PDF maybe of the questions in the description afterwards. All right, I guess we should get into it. Enough stalling. So this question says, Figure 1 shows a logo comprised of a rhombus surrounded by two arcs. Just a sec, sorry. Two arcs. Oops. Arc BAD has center C and arc BCD has center A. Some of the dimensions of the logo are shown in the diagram. Okay, so I guess they're talking about the length, the side length of the rhombus and the height of the rhombus. And it says, prove that the shaded area of the logo is 2 on 3 multiplied by 16 pi take 24 root 3. And this is an 8-mark question. Okay, so first, I guess the first thing to point out is you need to know some of the properties of a rhombus. So firstly, you'd want to know how to find the area of a rhombus. And some of the aspects of a rhombus. So the area of a rhombus is actually the diagonals, which we sometimes label P and Q, multiplied divided by 2. And also, in case I didn't mention, I'll be doing a GCSE question after this, so a bit of a random one today. You also need to know that the diagonals of a rhombus, this is GCSE level knowledge, they are perpendicular. So the diagonals are perpendicular. And something else about my writing's terrible, apologies. Something else about the diagonals, they bisect each other. So diagonals bisect each other. Okay, I believe that's all of the properties of rhombus we need to know for this one. So these lengths are going to be the same, and these two are going to be the same. Yes, T-Boy, that is A-level. This is an A-level question. I'll be doing a GCSE one after this. Alright, so a few things to note. Firstly, well, if this length's 4 centimeters, then OA will be 2 centimeters. Same for OC. So we could write down OA equals 2 centimeters. And we also have the hypotenuse of this right angle triangle in here. OAB must be a right angle triangle. So that will allow us to find the length OB. Why do we need OB? It's in order to find the area of the rhombus. We need this length DB. That's what I'm going to focus on first, just the rhombus, and then we'll talk about the ellipses, because these are not, they don't tell us they're circles, so we need to assume that's an ellipse. And we'll talk about that in a minute. Alright, so DB we're focusing on. So we're looking at this right angle triangle in here. So if this length is 2, the hypotenuse is 4, to find OB, well, that's going to be using the Pythagorean theorem. We can find OB, that's going to be the hypotenuse squared, take the other leg squared. So 16 take 4, root 12. Another way of writing that is square root of 4 times 3, or 2 root 3. Okay, now hopefully you notice something about this right angle triangle. If we draw it out over here, hopefully you notice something about the ratio of the sides. This leg was 2, this leg is 2 root 3, and this leg is 4. So they're in the ratio of 1 to root 3. And we know something about that right angle triangle. We know the angles of that right angle triangle. This one's going to be 60 degrees, this one's going to be 30, but we're talking about radians here because it's pi. So we need to write these angles in radians. 60 degrees as in radians, sorry. 60 degrees in radians, that's going to be pi on 3. And 30 degrees in radians, pi on 6. Okay. All right. So let's just, sorry about the barking. Let's just gosh. Let's just forget about those angles for a minute and talk about the fact we have these diagonal lengths of this rhombus. Sorry, just a second. Apologies for that. Yeah, so we have the length, the diagonals of that rhombus. We'll be able to find the area of that rhombus. So let's go ahead and do that firstly. Okay, so as we said, that's the diagonals multiplied by each other divided by 2. This one is 4, they've already given us that. We found OB is 2 root 3, so therefore this whole length DB will be 2 times 2 root 3, so 4 root 3. So the area is going to be 4 multiplied by 4 root 3 divided by 2. That's 8 root 3. Okay, we're looking for this orange we're looking for this orange area. Now we can't assume that it's a circle. We can't assume that it's a circle. They haven't told us it's a circle, so we have to assume it's an. Oh, do they say ellipse? Yeah, they don't say ellipse. They say it's an arc. When they say arc, it could be a circle or it could be an ellipse. Yeah, basically if it is a circle, it'll still come out with the same answer, but we can't assume it's a circle. I hope that makes sense. Anyways, we need to know how to find the area of a sector of an ellipse. Okay, so that's what we're going to talk about now. Area of sector of an ellipse. Okay. And there is a formula for this. It is a half multiplied by the angle of that sector, call that theta, multiplied by the two line segments. So if we called this line segment A, this line segment B, then it would be multiplied by A times B. In this case, both of the line segments have the same length. Both of the line segments have the same length, so we could just say that's the radius squared, the radius of that ellipse or that sector. And they've told us that side length of that rhombus is 4 centimeters. So this is where this angle comes into play. We found this angle up here because we were looking at this. We're looking at this right angle triangle, and we said that angle at the top, in the top of the right angle triangle, is pi on 3. Okay, so that means that entire angle would be 2 times pi on 3, or 2 pi on 3. Okay, so then plugging those in, we've got half multiplied by this angle in here, 2 pi on 3, multiplied by those two line segments, so 4 squared, which is 16. And let's simplify this now. Well, those 2's would cancel. We would end up with 16 pi on 3. So that then is this area. If I just rub this out for a minute, let's try to highlight this. That's this entire area inside this sector. That is a bit too big. Let's do it a bit smaller. That is this area in here. Okay. And we need to do that twice because we also need to include this area down below. So I want to find the entire area of this ellipse. So I want to do that again. And it's going to be the same, right? Because these two arcs would have the same area, or these two sectors, sorry, would have the same area. So the entire area of that ellipse would be 2 times this. So let's do 16 pi on 3, multiplied by 2. That would be 32 pi on 3. But what have we counted? We've kind of counted or double counted the area of this rhombus. So to find the actual area inside this ellipse without double counting those halves of those rhombus, we need to take the area of the rhombus away. Yes, this is an A-level question. I'll do a GCSE question after this. A bit of a mixed one today. Okay, so what I've just said is we've found the area of this sector, which also included half this rhombus. We found the area of the other sector, which included the other half. So to find the total area within this ellipse, subtract the area of the rhombus. And that was, where was it? 8 root 3. Let's try to simplify this. Multiply this by 3. This would be 32 pi, take 24 root 3 over 3. Okay, that is the area inside this ellipse. Then if we subtract the area of the rhombus again, we'll get the shaded area. I hope that makes sense. It's kind of, I feel like I'm not explaining that fully, but I hope that kind of makes sense why I'm subtracting the area again. So we're going to do this, 32 pi take 24 root 3. On 3, take 8 root 3 again, and solve this. Again, multiply this by 3, we get 32 pi, take 24 root 3, take 24 root 3 over 3. Simplifying this, we would have 32 pi, take 48 root 3 over 3, and then factorize out 2/3, 2/3. Factorizing 2 out of both of those terms, we'd have 16 pi, take 24 root 3. And that was what they were asking us to find. The reason I highlighted this question was because I rarely see this area of a sector of an ellipse formula in an A-level paper. If someone wants to correct me on that, if someone wants to say like, you know, yeah, it's pretty common, I've worked on that before, go ahead. But yeah, I thought I'd just highlight that area of a sector of an ellipse, an important thing to know for A-level mathematics. Okay, so there you go. That was a question from a pure mathematics topic paper. If there are any A-level students watching, hope you found that useful. Sorry, I haven't been reading the chat at all because Ollie was distracting me. So I missed a few things. Oh, T-Boy says it's common to see that. Okay, alright, fair enough. I mean, I've done, well, yeah, okay. Kahoot, yeah, we could play a game of Kahoot. On what topic? What do you think? I was thinking vectors because I did a live stream on vectors, so maybe going back to that. Alright. Okay, hopefully that was some A-level content. People have been coming in saying, let's do some A-level revision. So I thought I'd stick one of those in. And now I'm going to go back to GCSEs again. Formula for the area of a rhombus, PQ divided by 2. So that's the two diagonals of the rhombus. So AC multiplied by DB, or the average of those. Hello, Emma Violin Covers. Hello, Auntie Fufu. Alright. Okay, this is the question that I wanted, the GCSE probability question. Now I was thinking I'd try something different for this. I thought I'd put a timer up. I believe this is a 4-mark question. It might be a 3-mark question. So I thought I'd put a timer up. Let me know how this goes. If you're watching this video afterwards, feel free to skip ahead 4 minutes because I'm just going to put a timer up and I won't be doing any working out. So if you are watching the live stream, give this one a go. See how you go. So the question says, there are some red counters and some blue counters in a bag. The ratio of red counters to blue counters is 3:1. 2 counters are removed at random. The probability that both counters taken are blue is 1/20. Work out how many counters in the bag before any count. Work out how many counters were in the bag before any counters were removed. Okay, a bit of a typo there. Alright, so go ahead, give it a go, and see how you go. I thought I'd just try something new, see how it goes. But yeah, and then I'll go through the solution after this. So people were asking, should we give the questions a go during the live stream? Or just watch me go through them. So I thought I'd try this and see like what you think of it. Yeah, you could use tree diagrams for this. So again, if you're watching live, get a pencil and scrap paper out. See if you get this in the next 3 minutes. Hello ZTV, hello Blood Brothers. Blood Brothers is done, awesome. Maybe don't type the answer yet. So after the timer goes, feel free to put your answer in the chat. So I noticed a few people said another Kahoot, so we could have another Kahoot after this. Nicholas says, I want to do A-level maths and further maths. I got a 9 in mocks, but I'm scared for this year's exams. That's awesome. A 9, well, what can you say? I mean, it's natural to be worried, but that's a good thing. Use that for your preparation. But yeah, that's awesome. A 9 in your mocks. Congrats. Alright, so after the timer's done, feel free to post your answers. Oopsies. How do I get that back? Oh. There we go. So think about how you'd represent the total, think about how you'd represent the probability for blue and red, and then try to come up with an equation. I assume, I didn't actually see, because this question was sent to me in an email and they didn't include the marks, but I believe it would be either a 3 or 4 mark question. So I put 4 minutes up for a 4 mark question, but yeah, I'd say probably 4 marks. So you're working out how many counters in the bag there were before any counters were removed. Okay, 5, 4, 3. Alright, so I can get rid of that. Alright, so let's see. Well, if we've got the ratio of 3 to 1, so red to blue equals 3 to 1. Another way of writing this is red over blue equals 3 over 1, which we could just write as 3. So then it follows that the number of red counters is 3 times the number of blue counters. And you could just write that straight away from that ratio, right? 3 to 1, 3 times the number of blue counters. Okay, the total then. How could we write the total number of counters? Well, we've only got red and blue counters, so it would be red plus blue counters. And we've just said red equals 3 blue counters. So then we could write this, the total, as 3 blue plus 1 lot of blue counters, I guess, or the number of blue counters. 3 times blue counters plus 1 times the number of blue counters. Simplify that, it's 4 lots of blue counters, which is our total. So then, how could we represent the probability of picking a blue counter? Well, it's the number of blue counters, which we've called B, out of the total, which we've said is 4B. So then the probability of picking a blue counter, cancel the B's, it's a quarter. Okay. Not sure what's happened to this. Something's happened. Okay. Anyway, then we're looking for the probability that both counters taken are blue, or a way to represent that. And we talked about this in yesterday's video. How do I represent the probability of a blue and then another blue? We multiply them, right? We do, well, the first one's going to be a quarter, but because we're not doing replacement, how do I represent the second blue counter being taken? Well, the number of blue counters would then be B take 1, and the total would be 4B take 1. Total number of counters subtract 1. And this equals 1 out of 20, as they tell us. Okay, so that's how you're setting up your equation. Then you have to go ahead and try to solve this equation for B. And then it's algebra, so you need to be good with algebraic fractions as well. First thing I would do here is multiply by 4 on the right hand side, so I'd have B take 1 over 4B take 1. And then 4 over 20, do a note over here, 4 over 20, that would simplify to 1 over 5. So this equals 1 over 5. And then cross multiply. That's a common strategy to use to solve algebraic fractions. So 5 multiplied by this numerator and 1 multiplied by this denominator. So 5 times B take 1 equals 1 times 4B take 1. Expand those brackets. 5B take 5 equals 4B take 1. And then combine like terms, so subtract that 4B from the left hand side. 5B take 4B is a B. Negative 1 plus 5 is 4. Okay, so what was B again? B was the number of blue counters originally in the bag. So blue counters equals 4. And if we've got 3 times as many red counters, then we would have 3 times 4 red counters, so 12 red counters. To answer the question, the total number of counters in the bag before any were removed, 4 plus 12, 16. Okay, so I only saw Sam. Well done to Sam, who put 16. Good stuff. Thomas Hayes, would I do live stream? So I am a maths teacher. But yeah. Would be nice. I don't know. Okay, so total 16. And I always suggest doing what I call a reality check afterwards. So what do I mean by reality check? We'll just check that it fits in with all this information. Well, we already know that there are 3 times as many red counters. But what about this probability? So if I had 4 out of 16 blue counters, what would my next probability be? It would be 3 out of 15. What does this equal? This simplifies to a quarter multiplied by a fifth. This equals 1 over 20. So I always suggest doing a bit of a double check just to kind of reassure yourself that you got the correct answer. You and Eddie Wu are the only 2 people I've subscribed to. Wow. That is very flattering. Eddie Wu is one of my heroes. He's such an awesome maths teacher. Like, I could go on and on about Eddie Wu. He's such an inspiration. All right. Yeah, again, a bit of a short one today. 1 A-level question, 1 GCSE probability question. Any other topics? Other than that, we could play a bit of a Kahoot on vectors. See how everyone's going with their vectors knowledge. All right. See if we got 11 people playing yesterday. We'll see if we get as many today. It's every day. And it's a Friday, so taking it a bit easy today, I guess. There's that lovely Kahoot music. Alright, feel free to jump in. Come on, let's go. See if we can get more than 11 people joining in. I don't know if we will, but yeah. Even if you're A-level, why not? Give it a go. Oh, no one's... Oh, yes, we've got one person. Awesome. 2 people. Thank you, Nicholas and Kaz. Awesome. Year 10. That's brave. Good stuff. Circle theorems. ZTV says circle theorems. I guess I should have got some questions ready on circle theorems. I don't have any questions ready. If you want to send me one, then we can have a go at it. Awesome, 11 already. And all sensible names. Okay, 20 more seconds. Please jump in and have a go. 12, yes, we beat yesterday's number. Awesome. Alright, what did I say? 15 more seconds. Whoa, look at this. I didn't even know that was possible. 18. How did you do? Upside down writing. Okay, there we go. Let's get going. Hopefully everyone's jumped in. Let's go. And you can always jump in afterwards as well, of course. Find the vector OP. I'll cut this down to 40 seconds. When it gets to 40 seconds, I'm going to actually 30 seconds. I'll be generous. Then I'm going skip. Vector OP. Well done, A plus B. Okay, these get quite difficult actually. Let's see. Question 2. Find vector BA. Vector BA. So you're basically finding how to get from point B to point A in this case. So how would you get there? Direction is important. So if B is pointing this way, if you're going the opposite direction, it's a negative. Well done. Negative B take A. Sometimes written as A take B, but good stuff. Sam is in the lead. Well done, Sam. Question 3. Find AB. Find AB. Okay. The answer's kind of hidden a little bit. Different way of writing it. They're getting tricky. Ooh, yes, well done. So you had to factorize that after you found the answer. Bit of a tricky one. Well done to the 6 that got that correct. Tayyab is on a streak. Question 4. M is the midpoint of BC. Find BM. M is the midpoint of BC. All the answers are so similar, kind of makes it a bit tricky. I'll give the full time for this one. Oh, everyone's answered. Awesome. Well done. Well done to the 7 that got that correct. So it was negative S plus T. So half of that. Half of each one. Sam is still in the lead. Can somebody catch Sam? That's the question. Nicholas is hot on his heels. Yeah, it's easy to mess up on these. Below is a regular hexagon. Find CA. A regular hexagon. That's key. Find CA. Oh, fast timer on this one. Ooh, you have to be fast. Yeah, A take B. So that top side was also equal to A. Sam, pulling away. Let's go ZTV. He's on a streak. Below is a square. M is the midpoint of AP. Find MB. M is the midpoint. Find MB. This is so much fun. Thank you for playing, guys. I've been trying to cut back my Kahoot usage in the classroom, but it's different in a live stream. I don't know. Konaz, welcome. Feel free to jump in, even if you're just joining in. You can still give a few of these questions a go. Half B, take A. Well done. Good stuff. Yeah, these vector questions are pretty tough. And I guess the timer is pretty fast on some of them. Oh, ratios. So BM to MC is in the ratio 3:1. Find AM. Got a minute on this. BM to MC is ratio 3:1. That was pretty tough. You had to do 3/4 BC and then add that on. Okay, quarter S plus 3/4 T. That was hard. All right. Let's see. Wow. Sam doing really, really well. They're going to get tougher. M is the midpoint of AP and N is the midpoint of MB. Find ON. Could do 2 minutes on this. MB. The Kahoot yesterday was too easy. This one's too hard. I've got to find that middle ground. Ollie, hey. Oh, help. It's taking the lead. Well done to help. Below is a regular hexagon. Find PR. PR. So PQR. Okay. Q take 2P. Good stuff. Tayab in the lead. Last question. M is the midpoint of AP and N is the midpoint of MB. Find PN. PN. Okay, so the same diagram as before. Okay. PMN. Whew. Only 20 seconds on that one. Half A negative, half A take half B. Yep. Whew. Well done to the podium winners here. Tayab, number 3. Yolop in second place. Nicholas, well done to Nicholas. I would say that was upper year 10 level. Well done to Nicholas. That was tough. Those questions were hard. All right. Thanks for joining in. I don't know, we could do another. Well done, Blood Brothers. Oh, it didn't come up with 4th and 5th like it usually does. We could do another random one if you have a suggestion for a topic, or okay, algebra. Yeah, a bit stressful to do under a minute. I agree. Okay, let's do. Do some algebra revision. Surds, oh gosh, surds are so. I shouldn't say that. Surds is another suggestion. This looks alright. Some inequalities in there, some equations. Let's see. Alright, last one, and then I'll probably end the stream. Okay, so this one will probably be a bit less challenging, but we'll see how we go. Alright, jump in. Let's go. It's always good to practice your algebra. You don't want to be making those small mistakes in problems, like small algebraic mistakes that ruin your answer for like a whole proof. for a harder question. Maths is fun, I agree. Do you think method of differences? Sam says, do you think you can make a video covering the method of differences? Do you mean difference of two squares? Let me know. Alright, 10 more seconds. Oh wow. 23, 24. This is a record. Alright, that's it. Let's start. Oh, how do I stop it? There we go. Okay, how many solutions will the equation ax plus b equals 0 have if a does not equal 0? Whoa, that was fast. One. Okay. Question 2. How many solutions does 3x plus 5 less than or equal to 0 have? Yes, because it's an inequality. Well done. Wow, this is fast. Hang on, what's going on? Oh, someone... Oh, there's like some bot that's hacked it. Okay. I've seen this happen in other live streams. I'm going to try one more question. If they keep doing it, then that's it. Alright. Okay. Alright. Sorry about that. Thank you, Shish, for winning the game. Well done. Okay. Alright, so just to recap, we talked about the main point of this question was area of a sector of an ellipse, in case you hadn't seen that before for A levels. And probability question that we tried, we put a timer up and hopefully had a go at that one. Okay. Anything else while I'm here? I won't be live streaming on the weekend. And then back to school next week. So I hope you have a good weekend. And well, I'll still hopefully make a couple videos over the weekend. Check those out if you want. Oh yeah, the other thing that I mentioned at the start was I'd really appreciate, before you go, just before you jump out, I'd really appreciate your feedback, if that's okay. If you want, if you tuned into a live stream, I've put 3 questions in the description. 3 questions in the description. I'd really appreciate if you would leave a comment answering those questions if you want to. This is the last stream of this week. It's been every day, bro, this week. So next live stream, not sure when that will be, sometime in the evenings, possibly next week, not sure. But yeah, I'd really appreciate your feedback to the answers to the questions in the description. Basically, what do you think of the live streams? Any suggestions for future live streams? So if you could leave those in the comments of what you thought, I'd really appreciate it. And I haven't tried this before, but I could possibly try like a prize, like a random prize for a comment. So if you leave a comment with your feedback of the live streams, then I could put it into one of those random picker things and pick someone out for a prize. I'm not promising anything because I've never done it before. I'm not sure how it works, but I'll be looking into that because I really would love to hear your thoughts, and I'd love to give back if someone did share their thoughts on that. So yeah, check out the description. There's 3 questions in the description. Leave them in a comment below the live stream once it's posted. So not in the chat, but in the live stream. Sorry, not in the chat, in the comments. Okay, thank you for tuning in. Thanks so much. The live streams have been so much fun this week. I hope you found them useful. Please leave a like if you did find them useful. Subscribe if you want to see more content in the future, math related content, and have a good weekend. Bye for now.